So let's analyze what we just talked about. We said if I compound annually, so if I compound once a year, after 2 years, I owe p times 1 plus r to the t. Now I want to analyze this for a second because, I mean, honestly, who compounds annually? Like nobody. When you have your credit card, how much do they charge? Do they compound annually? No, they're going to compound monthly, right? If you buy a house on a mortgage, are they charging you annually? No, they're charging you monthly. So what we have right here, what this t really represents is the number of compounding periods. The number of times total. I'm going to say, another way to say that is the total number of times interest is calculated. So what happens if, say I borrow money and they'll compound it, say semi-annually. So say I'm going to borrow the same amount, $1,000 at 4%, compounded semi-annually. So that means, semi-annually means twice a year. Okay. So let's say after the first 6 months, so we'll just say after 6 months, they're going to say, all right, so-and-so person, you now owe me, let's calculate the interest first. The interest is going to be the $1,000 plus, but instead of charging you 4%, since we're calculating it, twice a year, we're only going to charge you half the interest. You say, wow, what a deal. All right, I'm making out like a bandit. So, oops, I can't, I'm getting excited. So I have an interest of $20, so the new amount that I owe is 1,000 plus 20, or 1,020. So like, that's awesome. Last time I owed 140. Yeah, but that was after 12 months. So let's compare 12 months and see if you've made out any better. Let's see. All right, well, remember last 6 months ago, we said you owed us $1,000 or $1,020, you didn't pay us. So we're going to count the interest again, but since we're doing it only twice a year, we're only going to charge you half the interest. What a bargain. So 1020 times 0.02. Wait a second, that turns out to be $20.40. So now all of a sudden, I owe $1,040.40. So something's not right here, right? Because before, after a year, where did it go? After a year, I owed $1,040 even. Now all of a sudden, I owe an extra 40 cents. How did that happen? I thought you really thought it was all going to work out, right? Because you only charged me half the interest. Yeah, but I compounded it twice. And that's the power of compound interest. When you look at the number of compounding periods, the total number of times the interest is calculated, the bigger this number gets, the more money that you're going to owe. That almost always tends to be the driving factor in how much money you owe. So we need to change our definition. So say I borrow P dollars at interest rate R. At interest rate R for T years. I'll say at interest rate R compounded n times a year for T years. How much do I owe? And here's the answer. Scroll down. All right. Now remember my equation before was this, p times 1 plus. But with the rate now, we said we weren't actually multiplying by the rate anymore, right? We were doing the rate, and what did we do with it? We divided the rate by 2 because we were compounding twice a year. So now instead of adding the rate, I'm only going to do the rate divided by the number of times I compound a year. So if you only compound twice a year, you divide by 2. If you compound 4 times a year, you divide by 4. But up in the top, we said that that's the total number of times that we calculate interest. Well, if we calculate twice a year for 3 years, we're really calculating interest 6 times. If we're calculating interest 12 times a year for 2 years, so think about this. If we calculate 3 times a year for 2 years, we're really calculating it 6 times. If we calculate it, 12 times a year for 3 years, I'm really going to be calculating interest 36 times. So like if you get a car loan, a lot of times you'll get a car loan that goes monthly, so 12 times a year for, say, 5 years, you're really getting calculated interest 60 total times. It's 12 times 5. So they're really calculating interest 60 times. So instead of just the number of years, it's the number of compounding periods times the number of years. So, 3 times a year for 2 years, 12 times a year for 3 years, 12 times a year for 5 years. That's the total number of times that we're calculating interest. So we have to include all of that. Okay? So this is your new equation. This can really mess things up. The thing is, like I said, you really want to get this number down as much as possible. So I don't know if any of y'all have a bookie. I've never had a bookie, but I've heard that they charge interest daily. So if you think that twice a year adding an extra 40 cents and your interest rate was only 4%, if you get 4% from a bookie, let me know because I'd like to invest some money with them. Most bookies are going to be charging, or those like cash, those payday cash places that are just, don't ever go there because they charge you like 80% interest, and they won't calculate interest monthly. They'll be calculating interest daily. So the more times that you calculate interest, remember that exponential curve? Remember what that curve looked like? It went straight up, right? So the more times you calculate interest, the higher up that curve is going to go. The less times you calculate interest, you'll kind of end up over here. So the more times you calculate interest, the worse off it is for you as a consumer. So you definitely want to be on your guard against things like that. Something that'll happen sometimes is, this is a real common scam that they'll try to run. It's not a scam because it's legal, but say you get a mortgage and your mortgage payment is $1,000. They'll say, well, I know it's really hard to come up with $1,000 at the end of the month. So what we'll do is we'll give you the option. You can just pay $500 twice a month. We'll just take it out of your paycheck or whatever. We'll just come up with an easy way to do this. You can just pay us on payday. No big deal, right? I say, well, that's fantastic. But what happens? Do you think that they're going to let you get away with this? Do you think they'd be offering it to you if they weren't going to make more money? Of course not. They're not in the business of, like, let's see how we can make the world a better place. No, they're in the let's see how I can make more money place. So if they're giving you the option to pay every 2 weeks, you can bet that they're going to be compounding interest every 2 weeks. So it's bad enough when you buy a house, because you usually buy a house for 30 years, compounded monthly. So that means they calculate interest 360 times, which is bad enough. But say you're doing this every 2 weeks thing, now all of a sudden they're calculating interest twice as often. So we'll give a rough estimate of calculating interest 720 times. And what a lot of people think is they'll say, oh, well, I'm dividing by n here and I'm multiplying it by here, so that must mean they cancel out. Well, they don't. And you saw that in the 40 cents that we carried over from just that small amount that we borrowed at a very low interest rate. This number down here and this number down here, even though it's divided in times, they do not cancel out. because this one up here is in the exponent. And like I said, we've seen what happens with these exponents. So while we're on the topic of mortgages, this is something else that, people will tell you. If you pay one extra mortgage payment a year, so, maybe you get your Christmas bonus, and so instead of, instead of paying 12 times a year, you say, okay, well, I'm going to pay my December payment because I owe it, but I got some Christmas money from work, so I'm just going to pay my mortgage twice. If you pay an extra payment a year, you pay off your loan, your house, about 7 years early. 7 years early, and you can save tens of thousands of dollars on that. The sooner you pay off your mortgage, the better it is, right? Because the sooner you pay it off, this number, that 360, will go down. The faster you can get that number down, the faster you're going to pay off your mortgage. Like, I'll tell you, my mortgage, I don't know what my payment is, but it's something like, just say it's $1,000. Right now, because I just bought my house like 2 years ago, only like $800 of that is going to interest. And only $200 is going to the actual loan. So it's like I'm doing this. I'm going payment, or my interest is going up and I do a payment. The interest goes up and I do a payment. The interest goes up and I do a payment. I'm not really making a whole lot of progress. You saw in California before the housing crisis happened that people were paying interest-only mortgages. Well, actually, my graph wasn't very good. So, I'm making progress because the interest will go up and I'll pay just a little bit down. I'll pay just slightly less, and then the interest will go back up again, and I'll pay just about enough to pull it down. Go up, and I'll pay just enough to pull it down. But this line is really like way down here, so it's going to be forever and ever until I pay it. So I've got to keep doing this, and the more times I do this now, the better, the more I'm going to be paying it down, but it does take a while to get there. So what you were seeing in California is people were doing interest-only loans. So they would buy their house, for $1 million, and they would have all this interest, and they pay just enough to get it right back down to $1 million. Get the interest and just pay it down. Interest and pay it down. So they'll have their house for 30 years, and they'll still owe $1 million on it. In London, when we went to London, they said that they were giving mortgages that were 50-year mortgages because it was too expensive to do it in 30 years. People couldn't afford the payments, but this is a 50-year mortgage. So if you buy a house when you're 20, then like when you're 70 years old, you might have it paid off. So it's like, wow, I'm really glad I can enjoy my retirement now that I'm 70 and have my house paid off. So you were getting charged 12 times a year for 50 years. So it's like, did I do that right? Yes. That's 600 times that they've calculated interest on this 50-year loan. So they are making a ton of money off of this. So what people will tell you, back to this kind of example right here, if you have a mortgage payment, say it's $780, and the bank says you owe $780, go ahead and round it up to $800. Because in 1 year, so you're paying an extra $200, right? So in 1 year, you're paid an extra $20. So in 1 year, you've paid an extra $240. If that's like half an extra mortgage payment. So maybe you won't pay it off 7 years early, but maybe you'll pay it off 2 or 3 years early. So by the time you're making a $780 mortgage payment, rounding it up an extra $20 one way or the other isn't going to impact your life too much, but it can really impact your mortgage in a fantastic way because of the power of compound interest. Now there's one more type of interest that you can get, and this is continually compounding interest, which is like every second of every day of, oh, look, I just breathed again, you owe me interest, and it's fantastic. I'm pretty sure that if bookies knew how to use the E key on their calculator, they would probably do that. So there's no real like n, there's no number for compound interest because it's not n times a year, it's basically an infinite number of times because it's every second, every fraction of a second every day. So you're going to use the E button, but this is the formula for how much you would owe using continuous compounding, and that's just about as bad as you can get. So we're going to do some examples using that formula, and so this is regular compounding. So I'm going to say n times a year. Remember, that's A equals P times 1 over R. Oops. P times 1 plus R over N to the N2. So we're going to use these in the next set of examples.